Hey guys, I'm on page 5 here of the reading, right after the reading guide for section 9.2. I'm going to do 2 complete write-ups for you involving hos and has, which is kind of crazy. And so this is the top of page 5 of your packet. So what we've got here is a question about American Idol. The purpose of this question, you can read through it obviously, but we're trying to figure out if there's an advantage to going last as the contestant. So you go up there, you sing, and then people call in and vote, and then the next person goes and sings and people call in and vote. And they're testing whether or not there is an advantage to being the last person. So there's like a thought process. Maybe we've talked about this in AP Psych. There's a thought process that the last person is the one to stick in your mind and the one you're most likely to vote for. So that's what we're testing here. And so from all of these words, what I'm going to talk about is we're going to first figure out what our ho and our ha is. Remember, the ho is the null hypothesis. It's not actually pronounced ho, it's H sub 0 or H naught. But I like to refer to it as ho because it's funny. Anyways, and there's also ha, which is the alternate hypothesis. So what we have here is a couple important things. 1/12, and we're wondering if there's convincing evidence that there's an advantage. So it's kind of hard sometimes to figure out what the ho and the ha is going to be from that. But because of this 1/12, the first thing that I'm going to do is I have my null hypothesis, which is the H naught. And I'm going to say that that is, and actually I'm not going to use an equal sign, I'm going to use a colon because we always have an equal sign in our initial percentage, or our proportion is 1/12. And because that is assuming that there is not an advantage to going last and everybody has an equal chance of being voted for, out of the 12 videos or the 12 contestants on American Idol, they should all receive 1/12 of the votes. And so that's our null hypothesis. Remember, the null always has an equation. And I'm using a p here because the proportion, you could do this as a fraction or a decimal. I'm just using a fraction. That means the proportion equals 1/12. So I'm not using an x or anything like that. We're trying to figure out if the proportion is 1/12 or if it's something different. And so again, to write our alternate hypothesis, think about how you would make this an advantage. Is there an advantage to going last? So the people that go last, what I want to test is it bigger than 1/12? This is a one-sided hypothesis test that we're doing here. So this is going to make my alternate hypothesis. Is P actually, in fact, greater than 1/12? Make a note that this is a one-sided test. So you talked yesterday about the importance between a one-sided and a two-sided. So sometimes the hardest part about these questions is figuring out what the ho and the ha should be. So again, what we have to do first is we have to state out all of the stuff. I'm going to state what the population is, what this P stands for that I'm using in my ho and my ha. I'm going to actually list the ho and the ha within my work, and I'm going to say what kind of a test we're going to do and why. That's all part of the state part of the state plan do conclude. So here's what my state plan all outlined looked like. So remember, if I go too fast, pause the video, copy this down. But start by saying what this P is. Remember, we're using this P in our ho and our ha, so it has to be defined. It's just like when we're doing a means problem and you have this random X in your work. You have to say what the X stands for. In this case, these are P's. They stand for proportions. And that's what I have defined here. It's the proportion of American Idol fans who prefer the last contestant. That's what I'm trying to study in this question. The population, who are we studying? It's all people who watch and vote for American Idol. So it's not all humans, it's not all high school students, whatever. This is just people who watch and vote for American Idol. I've got my ho and my ha, like I said, and then just a couple notes to explain why the ho and the ha are what they are. The null hypothesis is that all contestants are favored equally. Remember, for the null hypothesis, you always have an equal sign here. It's never a greater than or a less than or a not equal to. And then the alternate hypothesis is what you're testing. I'm suspecting that it's going to be greater for the last contestant, so that's what I wrote here. And then the sentence explaining what we're going to do, this is a really important part, and this is a huge component of the state part of this question. So since we are testing a claim, So we're not making an estimate like we were last chapter. When you do an interval, you're making an estimation, you're predicting something. In this case, we are actually testing a claim. We have hypotheses, so this is an important phrase. And we're testing a claim about a population proportion. That's why I have a P up here. And so for that reason, we're going to use a one sample, because I took one sample in the problem. I took 600 fans. And I'm using a Z-test, because Z's always go with proportions. Yes, later on we're going to get into T's, so that's coming. And it's for proportions, again, because I have P's in my problem. So next thing, as you guys know, we're going to have to go through random, independent, and normal, just like we did for confidence intervals. So I'm going to do that part now. So here's what the condition checks look like. So remember, going through random, independent, and normal. Random, you can't just say random check. State exactly what it is that is random about this problem. We have a random sample of 600 viewers, so there's our check. Independent, no, we don't call the viewers and then they don't have a chance of like calling back. So we are sampling them without replacement. We're not putting them back into the population and giving them a chance to be resampled. That's why I'm saying no. Technically this is not independent, but remember that 10% condition can apply here. It is reasonable to assume that more than 10 times 600, which is 6,000 viewers, it's reasonable to assume that more than 6,000 people watch American Idol. Okay, so that's why we have our 10% condition met. Make sure you mention what it is that you're doing here. Why did you multiply by 10? It's a 10% condition. Remember, the other textbooks use a 5% condition or do something else for independent, so you want to make really clear in your work what it is exactly that you're checking. In this case, we are checking the 10% condition. For normality, remember, we have formulas for proportions that help us check normality. Just make a special note here that these are actually P sub zeros. They're not P's. And that's because we have P sub zeros in our problem. They're actually called like null hypotheses. But it's our assumed proportion, which is 1/12, that is from our HO. So that's why make a small note about why those are not just P's or P hats like they were last chapter. In this chapter, they're P sub zeros. And so 600 is the sample size, and 1/12, that gives us 50, and then same thing for 611/12. So both of those numbers are bigger than 10. And remember, that means our sampling distribution of P sub 0 is approximately normal, or P hat, excuse me. So now I'm ready to actually do some math. One other thing that should probably be stated, since there was not a significance level in alpha to compare to once we calculate our p-value, we need to use 0.05, that's standard. And so I'm going to write out we're using 0.05 because there was nothing stated. And our p-hat is the 59 out of 600. It's those people that responded. The p-hat is right here. In this study, this sample that we took out of 600 fans, there were 59 of them that actually preferred the last contestant. So you could change that into a decimal if you wanted to, but it's not necessary. But that is the p-hat that we're going to be using in our calculation. So here's what our math looks like, you guys. Remember that this formula right here is written in this way on the formula sheet, but you need to know what numbers are supposed to go where. So the statistic is what we gathered from our sample, 59 over 600. The parameter is what we're using as our HO, 1/12. And the standard deviation of the sample, remember that there's a formula for that. You use your P sub 0 and then your 1 minus P sub 0 and then your sample size. And a lot of times the hardest part about these problems is typing this into the calculator correctly. Here is the number that we get, and remember what that equals is Z. And so this is actually our Z value. What we are doing here, this is this. And so then remember, it would take us all the way back to chapter 2. What I'm trying to find is the probability that Z is greater than 1.3929. And to help you remember why am I actually doing greater than, this number or this symbol should match this one. So that's why I'm shading to the right when I do my bell curve. No, you don't have to draw the bell curve, but to help you explain what's happening here is this is all back from chapter 2. I have converted using all my statistics and parameters and stuff into a z-score. And that z-score is right here, 1.329. Remember, a z-score means number of standard deviations. This is positive, so it's above 0. And I'm shading to the right, again, because that's this symbol right here. And that gives me an area, which you can find in the calculator doing normal CDF, or you can look at the table. That gives us 0.0919. That means that this shaded percentage here is about 9%. So here's what my conclusion looks like, you guys, to summarize. So we have this p-value. And remember, this p-value is what we are always comparing to our alpha, our significance level. And so in this case, the p-value is bigger than the alpha. And remember what like our saying is from Snoop Dogg: if the p is too low, which in this case the p is higher than this, if the p is too low, then the hoe must go. Well, in this case, since the p-value is actually not too low, that means that we fail to reject the hoe or the null hypothesis. So remember our options here for this: when you find your p-value, you either reject the hoe, which that happens when the p is too low, or you fail to reject. You never use the word except. That's one of those words in stats that you would lose all credit on the entire problem if you ever use the word except. Your options are reject or fail to reject. In this case, we fail to reject the null hypothesis, which was way up here. The null is the equal one. Since we're failing to reject that, I'm just going to restate what the null was. The proportion of American Idol viewers who prefer the last contestant is 1/12. That is exactly in words what this p equals 1/12 stands for. Another way of saying that, because if you look at what the question is actually asking us, do these data provide convincing evidence? That's a really common statistical question or way that they will ask the question. Another way to summarize or to conclude, which you would receive full credit for, is to say we do not have evidence that the proportion of American Idol's viewers who prefer the last contestant, I jumbled that up. We do not have evidence that American Idol viewers prefer the last contestant. So it's another way of saying we do not have evidence that the ha is correct. And so we do not have evidence that these are the words that say this. So we don't have evidence of that. So that is both different ways to do your conclusion. Either one of those is fine. So that was a really slow explanation of how to do a full write-up. What I'm going to do now is go on to this next problem about sexting, actually, which is interesting. And I'm going to go through this one quickly because it's very, very similar to the one that we just did, but just to give you another example to look at. So in this case, it's about a school counselor at a high school, and it says that the national campaign to prevent teen and unplanned pregnancy states that 20% of teens say they have basically sexted, and a counselor suspects that the number is higher. So you should be able to write your ho and your ha. The ho would be the proportion is 0.2. The counselor is suspecting, therefore our ha, our alternate, would be greater than 0.2. To find out, she gives a survey, and all 250 respond, which is important, and we have a p hat here. 63 out of those 250, whatever that percentage is going to be our p hat that we're going to use in our formula. And I have an alpha that is given in this problem. Remember, the earlier one we weren't given, so we defaulted to 0.05. In this one, they're giving us the alpha, which is still 0.05. So I'm going to start by stating all the stuff and then checking conditions. So here's all my stating just really quickly. I've got the population. It is the all teens at this high school. I have my P defined, which is the proportion of teens in this high school who have sexted. I wrote my ho and my ha. Remember, this is another one-sided one because the counselor suspects that it might be higher. That's an important word that's going to help us decide how to write the ho or the ha, and decide whether it's one-sided or two-sided. And again, what kind of a test am I going to do and why? We are testing a claim. Again, we are suspecting the counselor has a claim about a certain proportion, and we're going to use a one sample because we took one sample. Z always goes with proportions, so Z test for proportions. I'm going to go through and check my conditions really quick. I would encourage you to pause, write the conditions, and then check with mine. And here's what the conditions look like. Random, make sure you say what is random about this. We have a random sample of 250 teens at this school. Independent, no, because you probably don't ask them a question and then give them another opportunity to respond. That's called not sampling. Like we're actually taking our sample without replacement. We're not replacing them back in. However, it's safe to assume more than 10 times 250 is 2,500 students at this high school. The question did say large high school. Where did it say that? Right here, large high school. That implies that the 10% condition probably is going to apply here. So our 10% condition is met. And then for normality checks, remember we have two formulas for proportions to check, n times p sub 0. And our p sub 0 is our 0.2 that we're assuming is true up here. So, and then our 1 minus p sub 0, make sure you're not using the p hat, which is the 63 out of 250. We're testing our null hypothesis. These are sub-zeros here, so be careful about that. We have 50 and 200, both of those are bigger than 10, so that means that the sampling distribution of p hat is in fact approximately normal. Now it's time to do the math, and we're going to use significance level of 0.05 since it's given in the question. All right, so I stated what significance level we're using because it was given in the problem. The Z formula is your statistic minus your parameter over the standard deviation. So there it is with all the symbols. The statistic we're using is the 63 out of 250 that responded to the survey that said, yes, I have sexted before. The p sub 0 is our initial null hypothesis, what we're assuming to be true. And then remember, we use what we're assuming to be true in the standard deviation formula, so that's why we have 0.2 and 0.8 in the denominator divided by n. Hardest part sometimes is typing this whole thing in the calculator, so be careful. That gives us a z of 2.055, so remember that's your z value, and we're going to use that. That goes right here on our bell curve. Remember, we're trying to figure out the probability that something is bigger than that z value, and so that's where you're using normal CDF in the calculator or the table. I want to know the percentage of the shaded area. And then again, just remember that the reason why I'm using greater than here is because it matches this, okay? That gives us 0.0199 as a p-value, which is less than our significance level in this case. So is this p too low? It is too low. It's much less than 0.05. That means that the hoe must go. So that helps you write your conclusion. The p is too low, the hoe must go. So here's our conclusion, guys. Two different options on the way to write it. Since the p-value is 0.0199, which is in fact less than the 0.05, the p is too low. That means that the hoe must go. That means that we are in favor of, don't use the word accept, the ha. So what that means is we reject the null, that means the hoe must go, in favor of the alternate, and then restate what the alternate was, that the proportion of students at this high school is greater than 0.02 who sexed. So compare that to what we wrote above. That's really important to compare these two because that's the difference between these two problems. In this case, the p-value was not too low, so we failed to reject, and then I just restated what the null hypothesis was because we did not have evidence against the null hypothesis. In this case, the p-value was too low, so we rejected the null and we favored the alternate. So that's your other option, and then I'm restating what the alternate was because that's what we're favoring here, that the proportion of students is actually greater than 0.02. And so remember, that's another way that a lot of these questions will ask is, do you have convincing evidence? And so in this case, we do have convincing evidence that the proportion